Dear students, now the last part is discussing the clean and dirty price. You know, the valuation formula what we are using is clean price. What we are using for the valuation of a bond, the traditional formula of present value of coupons plus present value of principal repayment is equal to bond value. That is the clean price. But there is a kind of in between, there is a kind of adjustment. What is that adjustment? The coupon payment. What is that? For example, the first example, if you remember, that twice the bond coupons are paid. Once on 30th of June, the other one is on 31st of December. If that is the case, if the bond is traded on 1st October, then the seller, he will claim the interest for the period he holds the bond. He holds the bond for July, August, September, because last coupon is paid on 30th of June. He got the last coupon on 30th of June. Next coupon the buyer will get 31st of December, because he is selling the bond on, say for example, 30th of September is selling the bond. That means he holds the bond for July, August, September. The buyer will hold it for October, November, December. He will hold for 3 months, seller holds for 3 months. So the coupon whatever will be paid to the buyer on 31st December, it is for 6 months coupon. That must be distributed between the buyer and seller according to the holding. Agree? That is called the adjustment of the coupon. The seller makes the adjustment, demands for the coupon, he holds the bond with himself, is adjusted with the clean price. Then it becomes a dirty price. And dirty price is always clean price plus the accrued interest. Accrued interest means the interest the seller will demand for holding the bond for which he is not getting the interest. The buyer is going to get the interest from the company. So he will claim that portion from the buyer. So clean price plus accrued interest is equal to dirty price. And always write the equation, dirty price is equal to clean price plus accrued interest. And the relationship is clean price is lower than dirty price is higher than the clean price. So clean price is the quoted price. We have seen in the previous quote, the clean price is the quoted price. Dirty price is the price actually paid, that is quoted price plus the accrued interest. Example. Here the example is another one. We have taken the example 30th June the last coupon is received. That bond is traded on 30th September. So July, August, September. The seller holds the bond. So he will claim the interest for those 3 months. That is known as accrued interest. So example, consider the T bond in the previous slide and assume today January 15. Number of days since the last coupon is 61 days. Number of days in the coupon period is 181 days. The accrued interest will be calculated as 61 divided by 181 multiplied by 1.75 is the coupon divided by 2 because it is twice multiplied by the face value. The 1.75 is calculated from here. Yeah, 1.750 is the coupon, 1000 is the face value. So, and the dates are January 15, 61 because it is semi-annual, May 15th. So, it will be calculated as 61 days divided by January, means 15th May to 15th June, 15th July, 15th August. And 15th, the coupon was from the last coupon payment, the remaining days is 181 days. Total 6 months is 6 multiplied by 30, 181 days. Whereas 15 days, 15 January is 61 days since the last coupon is paid. 61 divided by, because the seller holds the bond for 61 days, so he will calculate the accrued interest of 61 days out of 181 days. Rate of coupon is 1.75%. Face value is 1000. So total coupon, the accrued interest 2.95 will be added with the clean price, that is the quoted price 972.11. 972.11. 97.2109 is equal to 972.11 or 109. That is the quoted price. Quoted price added with the coupon. The quoted price added with the accrued interest 2.95. So 972.11 is the quoted price, that is the clean price, plus 2.95 is the accrued interest, 975.06 is the dirty price. This you can calculate in the spreadsheet in no minute. Just simply we can calculate. I will show you how to do it in the spreadsheet. So you would actually pay 975.06 for 1000 par value bond. But the quoted price is how much? It is only 972.11. That's the clean price. But adjustment of accrued interest is for the number of days since the last coupon is paid. Then it will be dirty price. Inflation and interest rate, the real interest rate, once the inflation will increase, interest rate will increase. We have taken the example of Saudi Arabia. we have taken 2.5% interest. Once inflation increase, interest rate increase, again inflation increase, again interest rate increase. So interest rate, inflation go hand in hand. Nominal rate of interest is the quoted rate of interest, change in purchasing power of and inflation. The ex ante nominal rate of interest includes our desired real rate of return plus the adjustment for the expected inflation. 1 plus R is equal to 1 plus R multiplied by 1 plus H. 1 plus R left hand side is the nominal interest rate. 1 plus R, the capital R is the nominal rate, small r is the real rate. So 1 plus nominal rate is equal to 1 plus real rate multiplied by 1 plus inflation. Now if H increases, definitely the rate increases. If H decreases, definitely the nominal and real rate decreases, because 1 plus real rate multiplied by 1 plus inflation is equal to 1 plus nominal rate, or the nominal rate of interest is equal to 1 plus real rate multiplied by 1 plus inflation minus 1. Therefore, anytime H increases, nominal rate increases. H decreases, nominal rate decreases. So, R is equal to approximation. All these above calculation are very, very accurate. But you can make an approximation. Now, I am giving you the straightforward rate. Approximation is nominal rate of interest is equal to 2 straightforward real rate of interest plus inflation. If real rate of inflation is real rate of return is 5%, inflation rate is 2%, nominal rate will be how much? 7%. Approximation. For example, in Saudi Arabia, real rate of return, for example, 1 to 2%, inflation, for example, 2 to 3%, then the nominal rate will be 1 to 2% plus 2 to 3% is equal to around 4% will be the real rate. So most of the bonds normally not inflation protected, but very few bonds are inflation protected. One of them is TIPS, Treasury Inflation Protected Security, which is the as per the inflation, the TIPS rate is continuously being modified based on the inflation to adjust. That means, for example, the rate of return will be 2%. Inflation will be always added with the rate. If inflation goes up, TIPS rate will be goes up. If inflation goes down, TIPS rate will be going down. because the real rate 2% fixed. If inflation goes up, the inflation will be added accordingly. So always it will be going on modified because it is treasury inflation protected security. Fisher effect is R is equal to, we just discussed now, Fisher effect 1 plus real rate multiplied by 1 plus inflation minus 1 is equal to nominal rate. Here, for example, 10% is the real rate, 8% is the inflation, then what is the nominal rate? 1 plus 10% multiplied by 1 plus inflation minus 1. 18.8% will be the nominal rate. Approximation, just make the approximation now without making Fisher effect. Straightforward, 10% is the real rate, 8% is the inflation is equal to 18%, which is not accurate, but it is very close to the Fisher rate or the nominal rate, 18.8%. Because the real return and expected inflation are relatively high, there is a significant difference between actual Fisher effect and approximation. You see, here the real rate is 10%, very high. Normally, in Saudi Arabia, what we are seeing, we are experiencing real rate, maybe 1 to 2%. Normally, in US also the same kind of thing. The interest rate, again, the inflation rate also not very high, maybe 2 to 3%. But fragile economies, very much kind of developing economies, you will find the real rate of which very high, maybe, and the inflation is also high, and the volatility also high. So the approximation and the Fisher rate, there is a major difference. The Fisher rate gives 18.8, the approximation gives 18. There is a major difference. But if the real rate is, for example, 1 to 2%, in like, for example, our country, we see 2%, for example, real rate, 2%, for example, inflation. You calculate the Fisher effect, you calculate the approximation. They will be very close to each other. So, determinants of bond yield, term structure, we have discussed the price risk, the reinvestment risk with the term, with the coupon. So term structure is the relations between time to maturity and yields, all else equal. It is important to recognize that we pull out the effects of default risk, different coupons, etc. Yield curve is a graphical representation of the term structure. The expected yield if the bond is held till the maturity in a graphical representation. Normal upward sloping long-term yields are higher than short-term yields. Yes. Inverted downward sloping long-term yields are lower than short-term yields. Default risk premium, remember bond ratings. If the bond rating is low, default risk premium is high. If the bond rating is high, default risk premium is low. Because rating makes assured. If it is high rated, then there is no need to add high risk premium, low risk premium. Taxability premium, remember municipal versus taxable bond. So tax rate which you pay on the coupon. Liquidity, these are the factors affecting the required rate. Liquidity premium, bonds that have more frequent trading will generally have a lower liquid returns because it is frequently traded. Bid-ask spread will be very low. Anything else that affects the risk of the cash flows to the bondholder will affect the required returns. So take the I will float the smart book exercise within a week and make the practice. Any problem you face anywhere, anytime, feel free. If you want a personal kind of, I'll stop the recording here. Just give me a minute.